Hi, I'm Patrick Mannion, and I'm here at the Innovation Station at TE Connectivity at DesignCon 2020, and I'm here on behalf of ASCACorp, and we're going to discuss how TE Connectivity is solving problems.
So a couple of things we're going to talk about, Patrick, is how we're bringing technologies to market to solve customers' architectural problems.
Right.
And the big problem with 112 gigabits is the signal can't go as far unless we develop new technology for them.
And 5G as well, right? We'll talk about 5G.
That's right. So there's a big change happening in wireless, right? It's 5G, and that brings, it needs new antenna technologies and new interconnect technologies. And so we're working in bringing those to market as well.
Let's go see the demos.
So this is our OSF B Cable Assembly designed specifically for 800 gigabits per second, or 8 times 100 gigabits.
Right.
And the key reason we're holding this is to emphasize that we're able to achieve a 2-meter reach at 800 gigabits per second.
Nice. Yep.
And this is vital to our customers. When they look at the spacing of equipment in a rack, they need at least a 2-meter solution to be able to connect any box to any box.
Right.
And in this demo that we're looking at, we have an actual cable operating at 800 gigabits. So we're generating the signal here through 6 inches of trace, through a 2-meter cable assembly, another 6 inches of trace to another receive chip. And here we're monitoring the bit error rate performance of the cable assembly. We have also developed the OTB technology for using this cabling inside the box. Here we're outside of the box. Here we're going from the I/O port directly to the switching chip.
The chip itself,
and because of the loss or attenuation of the traces in PCB, they don't get the reach they need. And so by going to a twin-act structure, it's half the loss, and it gives us that reach back so the customer can get from point A to point B. The equipment doesn't get smaller when the data rate goes higher, so we need to find a way to get that reach back.
So now we're going to talk about a new way to do 112 gigabit per second using orthogonal connectors.
In our customers' equipment, they have I/O printed circuit boards that they need to bring traffic into the equipment. And then they have switch fabric printed circuit boards where they do the actual switching function. And they need to be able to get that traffic from the I/O board to the fabric board and then back out again. But the trick is to get that traffic from this board to this board with minimal signal integrity impact. So Patrick, in this demo, what we have is a Marvell chip generating 112 gigabits of traffic, and then that signal goes through 9 inches of printed circuit board trace. So we have a meandering trace. Then we go to our connector, we do the orthogonal turn to the other one, and then we have another 9 inches of PCB trace to another Marvell chip. So we're generating 112 gigabits. We're sending it through this 18-inch channel, which is about 33 dB of loss.
That's a lot,
And we're showing that we're able to achieve a very respectable bit error rate performance for this. We're running about 7 to the -9 in terms of the BER.
So I guess the main issue is that we have all these signals coming in and out of the chip, right? And they're getting larger and larger. So how do you handle the size of the chip and meeting the board so that there's no thermal mismatch?
The industry trend is to go to these ever higher data rates. And when they do that, their switching package must grow. When the package gets bigger, then it cannot be reliably surface mount attached onto the board. And that's where we've come along with our socket technology. So these sockets can support up to 112 gigabits per second. And we have 2 different technologies that we're showing today. This is our XLA technology, where it's a socket that is soldered onto the host board. So it's what we call an LGA to a BGA type of socket. And then the other socket technology is our dual compressive socket. And this is an LGA interface to an LGA interface. So it's a compression fit between the package device and the host board. And that's actually the operating demo that we have today. Here you see the resultant test pattern. So this is the eye diagram for this signal going through the socket. And you see nice, clear eye openings, So this is giving our customers the confidence that our dual compressive technology will be able to operate in their system.
So how does TE Connectivity address the thermal problem, which is getting pretty large, right?
Right, so as the data rates increase, the power dissipation increases. And that's a critical problem. So what we wanted to do is come up with an improvement on that technology, and we call it the thermal bridge. The thermal bridge is a series of metal plates that have compliance and resilience to them.
Okay.
but at the same time they're metal, so they're good thermal conductors. And so in the actual part, which is about this size, now we have this degree of compliance, so it can conform to each transceiver and it can conform to the heat sink above it. So it improves the thermal transfer. It lowers the thermal resistance. So imagine a cell site, a tower hanging up in the sun, and it has optical transceivers plugged into it, providing the data to and from the cell site. They need to cool that. And how can they cool that? They try and cool that to these fins on the base station.
Right.
But there's a gap between the top of the transceiver and the heatsink. And so how can they optimize that? And these are different technologies that are being used today. And you see the temperature indicated of the transceivers. This is with our thermal bridge technology.
33, that's a huge difference.
We have an actual operating module. It's dissipating about 10 watts.
Right.
And here we're showing the module thermal resistance. So this is the thermal resistance at the top of the module. This is the thermal resistance of the thermal bridge itself.
Right.
And then this is the thermal resistance of the heatsink on top of that.
Well, what are you seeing coming down the road in terms of what engineers are looking for future designs, right?
So where our customers would like to go eventually is a higher level of integration. They want to take those optical transceivers and bring them into very close proximity of the switching SerDes or processing functions. So in this case, we have a large switch chip, just like we talked about before. It's a part that needs to be socketed onto a board.
Right.
So we have the socket technology, we talked about that. And we've developed this CP2 Interconnect technology.
You see that?
It's very small. The contacts are on a 0.4 millimeter pitch. The overall height of the technology is a 0.5 millimeter.
Holy smoke.
So that means it has a very short electrical path,
Right.
which means it's going to have very good signal integrity performance. Now you have all these optical transceivers mounted right directly next to the switch chip. You know, we take that technology and we implement that onto the optical engines. So now when the customer goes to put his overall thermal solution onto the assembly, he has excellent thermal resistance between all the optical modules as well as the switch chip.
Right.
And so he ends up with a highly integrated system. It's socketable to his board. It manages the thermal problem, and it gives him the excellent electrical performance that he needs as well.
So now I'm going to change tracks for a few minutes and talk to Tushar about 5G and what TE Connectivity is doing to address 5G challenges. So Tushar, can you give us a rundown of what you're up to?
Yes, of course. So at TE, we are addressing all aspects of 5G, from the enterprise to wireless systems. Here we have one of our edge 5G RF coax connectors, compressible connectors. This particular product reduces the number of components from 3 to 1. Because of its low profile nature, it gives you a chance to increase the density of the connectors on the antennas, specifically 5G MIMO systems. And we feel that because of its capability on the manufacturing side, the total cost of the solution of this product is about 30% lower than what's out on the market.
So it is a kind of a 3-in-1 connector then, right? It
Yes,
solves 3 problems in one.
absolutely.
Okay.
Yes. One of the other things that TE is focused on is our antenna portfolio. Out here we showcase our complete portfolio of antennas. We've got a plethora of antennas addressing different verticals and different space in 5G and 4G LTE. This is another a great product for 5G. It is our massive MIMO antenna array. We've got these tuners that help us with the beamforming. So we not only help design these antennas, but we support the integration of the antennas into the wireless systems.
Thanks to Sharon and Nathan for taking us through this year's demonstrations at the TE Connectivity booth at DesignCon 2020, and I look forward to seeing you this time next year. Thanks for joining us.